Our next presenter is Stephen White from CSIRO. He leads the energy performance research at CSIRO. He's over 25 years of experience in energy use efficiency and electricity industry demand-side management. He is the operating agent for the International Energy Agency Energy in Buildings and Communities Technology Collaboration Program on Annex 81, Data-Driven Smart Buildings. He has oversight of key national energy use datasets and leads the Data Clearinghouse Digital Platform Initiative, and he has played a leadership role in the startup of several companies and the design of award-winning air conditioning systems. He's a member of the Australian Refrigeration and Building Services Hall of Fame and winner of the AIRAHs James Harrison Lifetime Achievement Award. He'll be talking to us about enabling flexibility from buildings. So please welcome Stephen.
Thanks, Ken, for the long play dance mix version introduction. And I'll be following on from Gabrielle and the work that she was presenting, and particularly focusing in, I guess, on what this means for consumers, and particularly in the buildings area. So the IEA work in the energy in buildings and communities, strong focus on thermal batteries, perhaps, as opposed to electrical batteries. And so the new annex that I'm starting up is IEA Annex 96 on grid integrated control of buildings. But the Annex 81 stuff on data-driven smart buildings comes to this idea of digitalisation and the new tools that we have at our hand to enable us to do flexibility. In all of this work that I've been doing, a lot of voice of customer work with people running commercial buildings and stuff, and what would they, could they, should they do in this space. So I'll start getting sort of reasonably philosophical on you, then drill down into some individual pieces of research we're doing. If I stray into anything controversial, hopefully that stimulates discussion and is not necessarily the views of CSIRO. All right, so not fit for purpose. Last week announced that there would be a review of the NEM. I think Muriel mentioned that. And I guess as I talk to consumers and I try to answer the question that Chris asked about why would I do this, I do feel that not fit for purpose for customers in the context of having distributed energy resources or consumer energy resources available. And partly it comes down to show me the money. In the old world, I was a consumer. I paid for my electricity, and my electricity got split up into little buckets there, some related to the wholesale energy market, some to the networks, some to the retailer, some for in the environment. And when it was one-way flow of electricity, it was one-way flow of dollars, and probably I didn't have to be too concerned about that. But right now, there's a whole bunch of resources that are now sitting with me that the AEMO ISP says they want to get a bit of in order to keep the electricity system going. So there we are. We've got the electric batteries, we've got the thermal batteries, so we've got hot water, and we've got air conditioning as thermal batteries. And we've been doing flexibility or consumer energy resources since day dot with our standby or our off-peak hot water systems. So we do know how to do this in some form or other. But the question is, the reason this becomes a thing is because in the new variable renewable energy world, these are the cheapest form of dispatchability. They've been paid for by the customer, so why on earth wouldn't we use them? But when it comes to the electricity industry trying to get a hold of my resources, suddenly the flow of money should be going back because they're the ones that want my resources, and we're struggling to understand how we actually can do that in the context of the existing structures that were built on the old world. So I ask the question, who's providing a service to who now? And it's not quite so obvious anymore. And indeed, if I'm a customer and I want to participate in the old world of the electricity system, it's a really hard gig to convince anyone to do something. If I'm trying to participate in the wholesale energy market there, I've got to do this bidding thing. Whoa, that's complex. And what? You can't tell me how often I'm going to actually dispatch my resources. That's a quantity risk there. I don't know how much I'm going to sell of this stuff, and you can't even tell me what the price is until after I've dispatched it. That doesn't sound very good. I've got to make an investment, and I really don't know what I'm going to get back for it. And to make it worse, there's the potential for penalties if I don't deliver. And then if I come to the network side of things, well, really, I don't know that I can see too many mechanisms for the networks to pay consumers for providing any service whatsoever. When it comes to a grid augmentation, perhaps there might be a request for proposals coming out. That's a really finite moment, and it's not very much money at that, and has been pretty unsuccessful. And indeed, the network's perspective on it is, rather than pay me, let's just shut you down, read solar backstop. So not much joy in the network either. And then when it comes to the environmental services, my flexibility actually could be used to match up with when renewables are available. But right now, the whole world is going gangbusters on net zero based on average emissions of the network. And so any sort of subtlety that I bring in terms of matching my consumption with my renewables gets no reward in that system. Well, I guess we'll just have to have our customer agents who will deal with that all for us, our retailer. To be honest, I'm not convinced that we're going to get the trickle down from the retailers, and quite probably will get captive into their ecosystem through the technology involved. So this is a problem if we're looking for 50% of all dispatchability in the electricity system to actually be providing the reliability for our system. So you've probably seen that from the ISP. All right, so flexibility, what is it? And again, there are lots of different sorts of flexibility. So again, it's a bit nuanced for my barbecue conversation. One model of flexibility which I think about and debate with my IEA colleagues is flexibility as continuous optimization. I've got some sort of controller attached to my flexible assets, might even be wireless enabled, and I may have an app that enables me to control it, and it's going to automatically start shifting loads around to prices of consume at least cost, or even consume when the price is negative. I was catching up with a colleague last week, and he was proudly showing me his retailer's app and showing how he had made a few dollars yesterday by leaving his air conditioner on during the day. So a continuous optimization is good, but will customers voluntarily go out there, buy these things? Obviously, my friend was a kind of a nerdy, techie kind of a guy and loved his app and seemed to be camped on it throughout the day. Will site optimization, okay, get the smarts there and I start setting things up to optimize things for me, but will that actually lead to a grid outcome? And there's certainly potential for fighting systems to be out there. And if I do optimize for the system, if I optimize for one bit, am I actually going to conflict with another bit? So that was one model, which is the continuous optimization, the economic optimizer, and it just goes through in my time of use or my grid spot pass-through price. Another model is where we look at the old traditional view of the world where we had base load power, then we had intermediate, and when the peak got up, lots and lots of demand, we threw in our peaker resources. Low run hours, but they could be high running costs because they were low capex. And I guess this model has demand response or flexibility as an occasional event of last resort. Quite a different model. I'm no longer continuously optimizing. Instead, I'm just calling on it at the last moment when it's needed in the energy system. Very low capex because it's being paid for by us. May have high running cost in terms of incentives, but that is indeed the incentive for why the customer would actually even bother through Show Me the Money. That model, it also has its issues. Can we feel confident that it's going to be there when we need it? Is certainly something that I worry about. And that comes to the question then of firmness. What is firmness? Well, in the old world, we had supply-side generators with real-time telemetry, SCADA connectivity, so industrial, ruggedized stuff, firm bids, penalties if you didn't deliver, and dispatch automated. Firmness there is firm because each asset that's being called upon is firm. If we put flexibility into that model, then flexibility is just a pseudo-generator. And to be honest, I can't see it happening with our small consumer energy resources. Here's another idea of firmness, which perhaps comes from the demand side. And this is us consuming as we consume. We can consume whenever we want. And we will have a site meter, which could be the spinny dial that gets measured quarterly. It's certainly not real time, even with the modern site meters. We'll have a flat or time of use tariff all smooshed across our energy system, and we'll get a bill in the mail. And is that firm? Well, in aggregate, we're feeling fairly confident that it is firm. And indeed, we build our electricity system off of this concept of after diversity, maximum demand, ADMD. And flexibility, or whatever's there, is a discovered behaviour that comes on a statistical basis. And so when we're looking at flexibility, should we look at it from that pseudo-generator perspective, or should we look at it at a statistical perspective? And a phrase that someone said to me, which I thought, yeah, that's what it's about. Are we cutting individual blades of grass or are we mowing the lawn here? That's that idea of treating everything as individual, or can we actually have a few high blades of grass, a few low grades, but on the whole, we've achieved a macro statistical outcome. Having said that, can't be laissez-faire. This is a graph from Ausgrid there showing trials on 18 small hot water systems, just showing the diurnal profile on a Wednesday. That's I think the blue and the green lines there showing the consumption of these hot water systems, obviously not on off-peak. Sorry, that's the red line. And then the blue line is on the Wednesday when they turn off the air conditioning systems late afternoon and bring them back on in the evening and end up with a problem that's worse. That is, you've broken the diversity, you've broken the statisticalness there if you just do a laissez-faire broadcast of a flexible request. So, is there a third way between that sort of let it, the thousand flowers bloom, do what they like and get firmness there versus that pseudo-generator? And what I'm sort of proposing in the middle there is this idea of small consumer energy resources having their own way of being treated. It's obvious that we're not going to have industrialized SCADA on it. It's going to use IT-type connectivity. That in itself is not a reliable way of doing things. And so you've already brought that uncertainty. It is already not a pseudo-generator. I think we can send out signals to people. Now is a good time to provide your flexibility. But I think it's a bit rich to ask them to put in firm bids and give penalties if they don't deliver. But having said that, you send out the request, you only pay on performance, and what you can do over time is build up an asset history and build up the statistics of these flexible loads in terms of their likelihood of delivering or not. So assets dynamically managed with voluntary incentives, flexible capacity is a discovered asset behaviour, but flexibility is still firm in aggregate because we do know enough about it using the Industry 4.0 IT connectivity. Oh, well, that was a long intro to a project, and this project is our New South Wales Digital Infrastructure for Energy Flexibility project. So we've been supported by the New South Wales Government and by RACE. Matt Amos is the project leader, and I'm just showing you some of the analytics as we sort of test out this third way concept. And in this, we've recruiting 200 buildings and 5 megawatts of flexibility to play with. So here we are. This is the setup of our project. We've got the building. We've got the flexible assets underneath. Those are the electric batteries, the thermal batteries, etc. And the posit is that in order to make this stuff visible, Gabriel mentioned that word visible as being a core thing. Now we're looking at it in real time. We've got to actually expose these assets to the grid. So we need a digital platform of some sort that does the job. This is going to require a new framework, so rather glad that there is a review going on now. And that framework, we believe, is going to have to track and learn baselines for all these things. That is, dynamically learn what these flexible assets are able to do. And clearly there would be some sort of data management, data capture, record keeping function there. So CSIRO developed the data clearinghouse platform specifically for the property industry, not just for flexibility, for all data-driven analytics. And what we're building here is this flexible demand asset register. Core to this is the idea that it would be providing transparent, interrogatable information on these flexible assets to multiple markets, to the wholesale market, to the network operators, and I've inserted, interestingly enough there, certificate schemes as probably the only demand-side mechanism that we have in place in our system. And so the core then of how do we kind of get this statistical view is the idea of baselining and using baselining to give forecasts and to also reward participation. With flexibility, it's a darn noisy type thing, so we believe that we can't rely on the NIMI data. We've actually got to have sub-meter data from the asset in question. So I think the flexible trader regulation was a core one that went through recently. But we're also asking for a demand response flag signal. That's a virtual data point streaming through saying, this asset is now believing that it's in flexibility mode, either flexibility increase or flexibility decrease for peak demand or minimum demand issues. Once we know that, using the non-event data, we can pick up the history and we can learn the baseline. And so I'm showing you a plot there of the historic data in blue, then goes into forecast in the mean forecast is the dotted red line and the 90th percentile confidence level is the shaded blue. And rather than just use one baselining mechanism that's approach that's meant to be good for everything, we've got about 16 different baselining techniques. And what we find is that different loads in different applications seem to respond better to different things. So we've got the simple Kaizo 10 used in the wholesale demand response mechanism, but then we've got machine learning, neural networks, the whole shebang there. And what we do is we take the ones that are the best predictors and we use those for creating the baseline. So that's looking backwards, creating our baseline and forecasting what normal would be. And then we go into forecasting what would you get if you did flexibility with these loads. All right, I'm going to bend your mind now here. So blue line is the historic data, goes into the dotted red, which is our forecast. And in this particular one, I've also overlaid over the top of that the green, which is what actually happened in retrospective. And you can compare that against what was what we predicted. And you can see it's not too bad. Key point here, this is a battery, so it's a bit more a kind of an on-offy type thing. You're either charging or you're discharging or you're doing nothing. So the forecast, which is averaging all that history, is not going to give you that on-off. It's going to give you some sort of median type thing. And so that's where you see the difference here, with the green line sort of going towards the extremes and the red dotted line, the forecast, being something in between. And interestingly enough, without actually any further observed data, you can say, well, compared with what is normal behaviour of this, I can work out what the maximum decrease or the maximum amount of battery power that I can push out, and I can work out the maximum increase by shifting to the extremes of that. And in that particular case, the forecast would have been pretty darn good. If I look later on there, when I compare the green line versus the red dotted line, I can see there's a bit of a gap between what the forecast flexible availability would have been in either increase or decrease mode. But don't forget, this is over. We're looking to do this over hundreds, thousands of assets, and so we don't have to get it precise on this asset. We have to get it, the precision is over thousands of assets. That's the mow the lawn, don't cut individual pieces of grass. All right, here's a more complicated one. Now we're doing forecasting, but we're modulating through thermostat set points. In this case, this is real data, 12 experiments of power increase, and each of the dotted lines is one of the 12 experiments, starting in the blue, which is during before the event. The red is when the event occurs. The green is after the event's finished. And what you can see is the deviation from the forecast, and the average is the black lines. And you can see it's chunked in 30-minute segments there. So for the 12 things, they didn't sort of hit bang on the forecast in the blue area, which is kind of what you would have expected. But what you do see is quite clearly the effect of the call for the thermostat increase happening. In the decrease mode, that's when the thermostat goes down. These 12 experiments didn't give such a great result. But it does show, I think these plots are important to show you how much noise there is in the signal, if you like, when you're dealing with these kinds of assets. But remember, we don't need accuracy on an individual device. We need accuracy across thousands of devices. And if they're not correlated, then you can see that even if you had plus or minus 50% on one, you're getting down to more like plus or minus 5% at say 5,000 devices. Of course, that brings you to the world of, well, are they correlated or not? In this particular case, we've got 20 real batteries and 37 HVAC systems that were being modulated. The 20 batteries were all from one company. And the red zone is where so x-axis is the device, y-axis is the device you're comparing it against. And what you see is the 20 batteries, when you compare each other, they're operating in a pretty similar way. Why is that? Because the battery operator is dispatching a signal. So they're actually relatively correlated, whereas the HVAC system is not so correlated. And that does affect the statistics on average. All right. So we've got ourselves some methodologies. We're in the process of testing them. We're getting good results that tend to show that we can, in large numbers, start to see the effects. How would you make this into a thing? If it doesn't work for the existing system, then how would you make it work, I guess? And I just throw out a couple of thoughts here. It's a presentation all on its own, I guess. But one, as I said, is those certificate schemes. It's the only deal in town on the demand side, and the peak demand reduction scheme in New South Wales has already sort of put out there for consultation what they call the WARM mechanism, Wholesale Annual Response Mechanism. These schemes already do baselines as part and parcel of their methodologies, and they're already moving towards that temporal granularity that is flexibility. Didn't get it through in the last round, but we're working with RACE sponsorship on our certificate scheme, which is focusing on annual, but in phase 2, looking to drill this into more flexibility solutions. The other sort of thing that flows across my desk is AEMO's CER data exchange. That's their map. Down at the bottom there are all the interoperability layers from device to device, device to customer agent. And then what AEMO's trying to do is create this data exchange at the top. That is to create transparency around the prices and transparency around the existence, sort of an extension of the DER register. So it is already heading in a very similar direction. And I guess what I'd love to see is a analytics layer embedded inside AEMO's CER data exchange, creating that dynamic perspective of what assets are able to do. And if we get it done well, we, with our baselining, hopefully we'll be able to allocate our flexibility across the different entities in the system. That is the network operators, the retailers, the aggregators, and the like. So summarising, traditional markets probably aren't fit for purpose for customers. Occasional event-based is in fact what's worked for flexibility in the past and is what is the dominant mechanism in the RERT already. And so digitalisation is the tool to bring us, I guess, down to smaller, more abundant mechanisms. And what we've got started on anyway in our projects is data-driven analysis of all these unscheduled assets and stuff. And we believe these kinds of techniques can provide a reasonable estimate of flexibility in aggregate and a fair payment system retrospectively, reduce the administrative burden, and in using something like the PDRS, provide an incentive for customers to really participate and get the price signals they need to be able to offer this stuff. Thanks.
Thanks very much, Stephen. We have time for one question. Rebecca.
Thank you. Rebecca Young from AIRAHs University. Thank you, President, for the meeting. Rebecca Young from AIRAHs University. Thank you for the exciting presentation. I'm interested in the mid-rise to high-rise buildings. So currently, I'm supporting the Victoria government in looking to the energy flexibility in Sunshine Precinct because the government wants to put in 20 billion something to demolish that area and build hundreds of new buildings. We face two challenges when we do the work. In theory, there's great opportunity for us to engage more distributed renewable energy, battery, EV in that area, and link to virtual power plant and demand response, and generate a lot of revenues to that area. But there are two challenges in relation to this. One is that we talk about 2050 scenario. So we talk about to secure the benefits to the customers or investors. It's because of the uncertainty in the future, it's very hard for us really to quantify the economic benefits in that way. That's the first challenge. The second challenge is that because for single buildings, the energy flexibility, especially in relation to the demand response opportunities, it's very limited. So the best option is to aggregate the entire area and into a virtual power plant, for example. However, in order to achieve that, it needs coordinations between DSPs, retailers, aggregators, and investors, property developers, and governments. How can we achieve that?
I think you've articulated the problem that I was articulating at the in a very specific and tangible way. So I appreciate that. And to be honest, I don't think the mechanisms are. Clearly, a money flow can help to overcome that. You know, I guess I do sort of have a mentality that is a follow the money type thing. So if there was the incentives that gave you certainty up front, and I did point out, that the lack of certainty is one of the problems, that sort of helps to deal with the economic piece. Large-scale development, there's the emissions story, the ability to match renewables, and we've done some other research there where we've taken the dynamic time of use emissions signature and worked out that net zero only probably gets you down about 50% in terms of your real emissions. So this sort of net zero based on averaged annual emissions factors is a furphy and needs to be dealt with. So there's an environmental thing, which sometimes goes into the obtaining the finance to actually make things happen, particularly on large-scale developments. And Green Building Council is all over this and creating a lot of incentives there in terms of credibility and things like that. But that's just the start, and hopefully reform will happen to enable these things to move along.